Hey guys, what's going on? My name is Jeff. Thanks again for joining me in this video. So I just kind of want to give you guys an over of Gen Phys 1 and kind of what it actually covers. But just to kind of give you guys a little bit of context. So if you're kind of going through your normal undergrad physics courses and curriculum, so the first course that you're going to take is obviously Gen Phys 1. And so that's going to really be going over mechanics. So it's pretty much just kind of like macroscopic motion. So that's really just kind of your Gen Phys 1 stuff. And again, I just kind of want to give you guys just a little bit of overview just so you kind of know where this would fit. The next kind of main area that you're going to be going over is E&M. So you can go over this at a lower level in Gen Phys 2, or you can go over this at a higher level in your actual E&M course. It's going to be called E&M, but I'll just say this is like Gen Phys 2. And then if you do it at a higher level, it's going to be called electricity and magnetism or electromagnetic theory or something like that. And then just kind of the last realm, here I'll just call it quantum. So at a lower level, this is going to be called quantum physics. And then at a higher level, it's going to be called quantum mechanics. So, and I guess I should be a little more specific. Mechanics, this is going to be like your macroscopic mechanics. It's not going to be your small mechanics. Here I'll say like large mechanics and then small mechanics. So this is just kind of like a super brief overview, just so you guys can kind of get a little bit of an idea of what Gen Phys 1 is going to go over as compared to kind of like the other, probably like two major realms. You could probably maybe throw some other realms in here, but just in terms of undergraduate stuff, this is pretty much the core of an undergraduate physics course load, basically. Okay, so now that that is out of the way, I kind of want to go over, so basically like what is Gen Phys 1 actually going to go over? So again, I called it kind of like large mechanics. I'll sort of call it, I'll call it macro. You see that? So macroscopic mechanics. So that is pretty much what Gen Phys 1 is going to be going over. Now, what are going to be the different realms of sort of this macroscopic mechanics thing? The first one is we're going to call it the description of motion. So, we have something that's just sitting there, we have something that's moving, we have something that's accelerating, and we want to be able to describe that motion. So that is going to be our kinematics. So just, how do we describe motion? Cool. So the next realm is going to be, we'll say, it's the reason for macroscopic motion, slash, I'll say, reason for changes in macroscopic motion. So let's draw a little circle around this guy. So again, we have the description of motion, and now we have the reason. There we go. I'm still trying to figure out this whole thing. The reason for changes in macroscopic motion. So this is really going to get into, part of this is going to be Newton's laws. Newton's laws. Well, not part of it. I would probably pretty much say all of it, actually. Newton's laws. I was saying part of it because in my mind, we do have, when motion is not changing. So, Newton's laws, F equals ma. Well, if it's not accelerating, if its motion is not changing, then its motion is conserved. And when motion is conserved, it gets into a little bit of the study of momentum. But I guess here, I'll just draw this. I'll say this momentum. Because if the change in momentum is 0, then the net force is, 0. If momentum is changing, then the net force is not 0. But again, I don't want to get too much into this just yet, but I would definitely put momentum kind of like in this bubble. So the reason for macroscopic motion, and then the reason for changes in macroscopic motion. It's going to be Newton's laws. You're going to get into the idea of momentum and all that fun stuff and all the implications of that. So again, we kind of have this description of motion. We have the reason for this motion, the reason for the changes in this motion. After that, you can kind of talk about a little bit of a different conceptual entity, where you can start talking about energy. So I'll say energy of particles, energy of, just energy of systems. And then once you kind of start talking about this, you can sort of get into when energy is conserved or when energy is not conserved. So we'll say when the change in energy equals 0. So just what happens when the change in energy is 0, or how do we know that the change of energy is 0? And then we also have the other case when the change in energy does not equal 0. So when energy is changing. And this is going to get into the concept of my favorite, work. If you really understand work, then you'll be really good in your physics classes, because as you kind of go along in physics, you're going to start moving away from motion and you're going to start moving into energy. Just kind of like the conceptual focus is going to be less about motion and more about energy. And if you really understand why energy changes, and if you really understand work, then you're going to be just fine. So that would be that. So again, we got the description of motion, the reason for motion. We got two things that are kind of interacting. It's probably going to be, it's going to be the energy of a system. If you got something that's just going along, you're going to be talking about its kinetic energy. Okay, that's great. Kind of the next realm is really just going to be the realm of gravity. So you can't get through Gen Phys 1 without studying gravity. It's a pretty important thing. Oh, I wish that was straighter. Sorry about that. So you're going to be talking about the force due to gravity. The whole negative GMM over r squared r hat. So yeah, just talking about gravity, talking about the Earth being pulled by the sun. You throwing something up and calculating the force of gravity, on it, your mg, I'll say, and also mg. So it's going to be all that good stuff. The next realm for Gen Phys 1, so as you kind of start talking about gravity and, like things orbiting, things are kind of going in what? They're kind of going in this circular motion. So that is the next kind of big realm that you're going to get into. So I'll say rotational motion. So do you guys kind of see how all these areas kind of start to build on each other? Like, we're going to have the description. And actually, even before this, I could say you're going to talk about the units of physics. So, oh shoot, hold on. My thing is like running low on battery. I got to plug this thing in. Let me make sure that I have enough. 10%. Okay, yeah. Let's see if I can get this done with 10%. All right, sorry about that. My computer or my phone kind of wigged out and I'm running a little low on battery, so I'll try to get this done. I think I should be able to. But yeah, as I was saying, do you guys kind of see how this is sort of building? We have this description of motion, and what I was saying just before that is, even before this, we could do a little. The first thing that your book is going to talk about is kind of like the units of physics and the dimensions. So, or here I'll say like units, so units of length, so we got meters, units of mass, we got kilograms, and then units of time, we have seconds. So like we kind of just start with the most basic, and then we start with describing motion of, like just some little particle. We get into like the reason for the motion, the changes in motion. We can talk about like kind of the energy of that particle. If it's a system, we can talk about the energy of the whole system. We got this gravity thing going on, so there's going to be gravitational potential energy between our planet and our sun, or our two planets or something. Those things are going to be rotating around each other, so we can kind of start to describe its rotational motion. So there's kind of like a whole flow to how this thing goes. This is probably going to be the hardest area of Gen Phys 1. This is when you're going to get into your moments of inertia, and we know how much everyone loves that, but honestly, if you understand it, it's actually really, really pretty cool. It's really just the rotational analog of mass. But yeah, this is going to be a heavy hitter, and you're definitely going to want to study up a lot for this. After this, you can kind of get into a little bit of equilibrium. Equilibrium. So, this is going to get into, like let's say we have somebody standing on a ladder or something like that. You're going to balance your force pairs. You're going to make sure that the net torque on the system is 0. And if it's not 0, then what's going to happen? So you're going to kind of get into like systems that are at equilibrium. So this is not no point particles. No point particles. So you're just going to be talking about systems that are at equilibrium and how you kind of know that. All right, well, that's great. The next part you'll probably get into is going to be your wave motion. Yeah, it's kind of, I would say the climax of kind of Gen Phys 1 is going to be your rotational motion, and then it kind of peters off a little bit. Your wave motion, I mean, it's going to be calculating the period of stuff. It's going to be calculating the angular frequency of stuff. Okay, like that's fine. Not anything too crazy, but I mean, but as you go along in physics, you'll realize that kind of like everything starts to behave like a wave. So even though this might at first not seem too exciting, I mean, I wasn't too excited about it initially. If you really understand it and if you really start getting it, then it's actually going to become a really important part. Because you'll definitely be using wave motion in quantum, I'm pretty sure, even though I haven't taken quantum yet. And then after that, if you guys are lucky, if your school has time, you might get into just the area of thermodynamics. So I'll just call it thermo. I haven't quite really ever studied thermo on a formal level. I've done it a little bit in my chemistry class, but I wouldn't at this point know how to completely tie thermo into kind of like these other areas, because thermo, it's really just like the study of heat, and like the transfer of heat. It definitely does get into changes in energy, because heat is a form of energy. Thermo, it's actually a super important area of physics, because, well, so it is a super important area of physics because it's so general. Like it makes super general claims, such as like, entropy in a general sense always has to be increasing. It's not necessarily that the entropy of a system always has to be increasing, but as you keep expanding your system outward, then the entropy does have to be increasing. So it just makes, and so entropy, kind of like disorder or like random motion or something like that. So it starts to make kind of like some super general claims, but it's definitely not, I mean, heck, we actually didn't even cover it in my Gen Phys 1 class. So to just kind of like put, again, everything in perspective, I'll just do another little quick thing here and then I'll be done. So really what Gen Phys 1 is going to go over, just to kind of tie it all together and kind of use the names that your textbook is probably going to use. So the first part, the description of motion, is going to be kinematics. So just how do we describe motion? All right, that's great. The next part is going to be Newton's laws. So we're going to be talking about, yeah, just like changes in motion, but not always, because, you know, something could just be moving at constant velocity without changing its motion. That's due to inertia, and Newton's first law talks about that. But yeah, so after kinematics, we'll get into Newton's laws and like motion and changes in motion. After that, you're going to be getting into energy, and kind of, you know, when energy is conserved, when energy is not conserved, and kind of the concept of work. And then after that, you're going to get into the study of gravity. So, you know, two planets, a planet and the sun, you know, just all that fun stuff. After that, you're going to get into rotational motion. So things that are spinning. You're going to get into torque. You guys can watch a lot of fun videos on torque and how all that stuff works, and do all your cross products. After that, you're going to get into, you're probably going to get into the idea of equilibrium. I'll just say equal. So, you know, when the net torque is zero, when the net force is zero, you're going to get into the idea of equilibrium. After that, you're going to get into the idea of waves. So it's kind of just a different way to describe motion, not just things going along on a straight line, but it's just kind of like a different type of motion, I guess. And then if you're lucky, if you guys have time, you'll probably get into the realm, I'll say, thermodynamics. So again, that's going to give you kind of an intro into heat, an intro into entropy, and yeah, definitely not the main focus of Gen Phys 1 at all. I would definitely say probably like Newton's laws, and probably like energy and conservation of energy are going to be your main areas of Gen Phys 1. I'll put little check marks. So if you can master these two, then you will master Gen Phys 1. So yeah, I hope that this video was helpful for you guys. Hope you have kind of a little bit of a better understanding on what Gen Phys 1 goes over, kind of how the pieces kind of fit together. Yeah, and I hope to see you in another video. Thanks.